Hello, good day to all. So, for this, for today, I will be discussing to you the lesson 5 process synchronization. Okay, so process synchronization is actually one most important topic for the operating system, since we all know that to improve CPU performance, and to improve the memory allocations or utilizations, we need to synchronize all the processes. So first of all, why processes have to be synchronized, or what is the need of process synchronization? Again, to improve the process and memory utilization, we will always go for multi-programming. If you can still remember the topic we had for the thread, wherein we also tackle the single threaded and the multi-threaded. Then how is it important for us to have a multi-threaded processes, so that we can have a faster and a more efficient uh, multi-processes or multi-programming of all of the data that we are using within our operating system, or with the operating system processing. Okay, so mm a single processor, we are using one process in the main memory and at the same time, and as a result, a number of processors, if you are using a number of processors or more than one process, can be parallelly or concurrently executed. So that is what is being defined here. So processes can execute concurrently. So meaning to say, when we say concurrently, simultaneously or at the same time, or mm, parallelly, or like that. So it may be interrupted at any time and partially completing execution. So concurrent access to shared data may result in a data inconsistency. So that is what we are trying to discuss here. What are the most common problem when it comes to reasons or problems that can occur with process synchronization? So the most common or the most classic problems of synchronization is what we call producer-consumer problem. So this is very common, the producer-consumer problem. So when we say the producer consumer problem, which is also known as the bounded buffer problem, is again a classic example of a multi-process synchronization problem. So the problem describes two processes. So we have the producer and then the consumer. They share a common fixed size buffet used as a queue. So this is what we call a data buffer, or a buffer of n processes. So mo gitawag na to a fixed buffer used as a queue. So they shared one data buffer, the producer and then the consumer. Now, if there are problems between a producer consumer, so that is where we have a problem with our synchronization. So the the producer job is to generate data and then put that data into this buffer. So this is what we call a buffer of n slots. So just for this illustrations, we have I think we have 7 buffers. So kaning producer consumer problem, they shared they shared a data buffer, and then this producer job is to generate data, meaning to say to store data into this n slot. So mabutang siya mga data dire, he will insert data into these slots, and then it will start again. At the same time, this consumer, C1, C2, C3, this is considered to be a consumer, is consuming the data. So whatever the producer whatever the producer tries to put the data into this n slot, the consumer consumes those data. Meaning to say, the consumers will remove the data from the buffer. So si producer will put the data into the buffer, will insert data into the buffer, and then the consumer will remove data from the buffer. So this is what a consumer this is really a producer consumer scenario looks like. So what the producer does again is it will produce data and store it to the buffer. That means it will insert data into the buffer add, and what the consumer does is it will consume data from the buffer, and that means it will remove the data from the buffer. So what are the things we need to take care of when it comes to this? So if in a perfect world, if the producer and the consumer is synchronized, or if they are perfectly working with each other, then there's no problem. Now, what we are trying to see things is that what if the producer and consumer is not working concurrently, meaning to say they are not properly working with each other. So uh, uh, that is why we need to find solution, or we need to take care what is that, if there are actual problems, or there are common problems that occur when the producer and consumer problems occurs. So the common problem, or the problem that will arise when there is no, or when the process synchronization, or when there is no process synchronization, it will be when the producer must, with this one, when the producer must not insert when the buffer is full, meaning to say when these buffer are full, therefore the producer cannot insert, or the producer cannot uh, store data anymore. And the number two problem is when the consumer cannot remove data when the buffer is empty, or is not allowed to remove any data from the buffer, because there's no data after all that are being installed, or that were being installed in the buffer. And then the third problem is when the producer and the consumer should not insert and remove data simultaneously, meaning to say uh, when the producer is trying to store data, and then the consumer tries to remove data from the buffer concurrently, meaning to say at the same time, and that is where the problem occurs. It will the process will go berserk, meaning to say the process will have trouble, because they are not working simultaneously, or they are not being synchronized. So that is the three most common problem with the producer consumer problem. The first one is the producer cannot store data when the data buffer is full. And then number two is when the consumer is tries to remove data, but when the consumer tries to remove data from the buffer, but the buffer are empty. And then the third one is when the producer and the consumer tries to uh, access the buffer, like the producer will try to store data, and then the consumer will try to remove data at the same time. So that is the three most common problem. Now, there are some processes that may, however, help with this kind of problem. So we have a race condition. So a race condition is the situation where several processes access and manipulate data concurrently. The final value of the shared data depends upon which processes finishes first. So it is possible to have a software system in which output depends on the sequence of events. Meaning, in this case, the events do not occur as to the developer wanted, or whatever the developer wanted to have in that system, and then that fault is considered to be a race condition. So in case the event do not occur as a developer wanted, a fault happens. So that's what we call the race condition. So a race condition can take place when multiple processes or threads operates on a shared data. So it meaning to say concurrent programming, so meaning to say simultaneous programming at the same time. And we also have a critical section problem. So when we say a critical system or a critical section problem is when we have when it is considered a system when the end processes, like let's say processes 1 or processes 0, processes 1, or uh, processes 2. So let's say So a critical section problem is, you have to keep in mind that when we mean process synchronization, cooperation process, meaning to say all the processes are in tune, meaning to say they are cooperative with each other. So we have to synchronize these processes. So between each process, in such a way there will be no data inconsistency. So in the data that we are having, so that it will remain consistent. So with regards to that, we will have also tackle what is critical section. So critical section also contributed to a problem that may arise when it comes to process synchronization. So we considered a system consisting of, let's say, we considered a system of n processes, so processes 0, processes 1, and each process has critical section segment code. So each process contain a critical section. So a process may be changing common variables, updating table, writing file, or etc. So when one process is in critical, no other may be in a critical section. So with each process is a segment called a critical section. So with each process, sometimes it may change the common variable, updating a table, or writing a file, and so on and so forth. So that means that whenever a process is using the shared memory or making any manipulation in the shared memory, then the code that is responsible for doing that particular operation is known as critical section. So again whenever the process is using the shared memory or making any manipulations in the shared memory, then the code that is responsible for that particular operation is what we call critical section. So the critical section is the segment of code of process in which the process will be changing the data in shared region of memory. So that is shared between different processes. So that is about what we mean by critical section. So for example, when this general structure of processes. So for example, when one process is executing in its critical section, no other process is to be allowed to execute in its critical section. So that is, no two processes are executing in critical section at the same time. So again, to sum it up, so the portion of code which will be responsible for changing the common variable is what we call the critical section. So a critical section problem is to design a protocol that the system can use to cooperate. So meaning to say, I already mentioned operating process earlier, or the intunes of all the processes. So are the processes that are sharing the data. So when they are cooperating, when the processes are cooperating, when the processes are being in tune with each other, they are, as a result, they are synchronized. So what do you mean by synchronized? So when we say synchronized, they should not use the shared data concurrently, meaning to say it has to be properly arranged, or it has to be properly allocated into the memory. So there's a certain rules to be followed. So this is actually a snapshot or a snip of mura ba siya og kanang flow or a certain rule to follow whenever we are, or whenever the process or whenever a certain process will access a critical section or operating in a critical section. So what are they? Each process must request permission to enter its critical section here. And then the section of code implementing this request is the is the entry section. Then the critical section may be followed by an exit section. And then the remaining code is the remainder section. Now let's see here. This is actually a do while loop example. This one, a general structure of process or P1. So this is a typical do while loop. So inside this do while loop presentation is this is the do. So this is a structures wherein a process is already in the critical section, and then a section code is implementing into an entry section, meaning to say an entry section is already inside or inserted or inputted in the critical section. Then after the critical section, it will be followed by the exit section. So in the exit section, the remaining code will be uh, installed or will be stored in the remainder section. And and then the solution, and then it ends there. Now there are some of the solution in which uh, it must be satisfied, in order for us to solve a critical section wherein there are rules to be followed. At the same time, there are rules, or there are things for us to do, so that we can satisfy the critical section, which is, it's very we call it critical because it is very important for us to be able to get our processes synchronized. But we have to satisfy these three following requirement. So we have the mutual execution, we also have the process, and we also have the bounded waiting. So when we say mutual execution, it is a process, or if the process is executing in its critical section, then there is no other processes that can execute in their critical section. Meaning to say, no process can execute, two processes can execute at one point in time at the same time when you are in the critical section. That's why mao ni siya diri ang ato ang rules to follow, or the structures to follow, when we are trying to access a process in a critical section. And then we also have the progress. So if no process in executing in its critical section, if there are no process in executing in its critical section, then there exist some processes that wish to enter into critical section. And then exist ng mga processes that tries or that wish to enter into the critical section, then the selection of the process that will enter into the critical section next cannot be postponed indefinitely. So meaning to say, at the point of time when there's only one process that execute in a critical section, then it can be taken. Okay, so if there are no processes in executing in its critical section, and there exist some processes that wish to enter their critical section, then the selection of the processes that will enter the selection section next can be postponed indefinitely. Now, how about the bounded waiting? Now, in the bounded waiting, a bound must exist on the number of times that the other processes are allowed to enter their critical sections. After the process that has been made request to its critical section, then therefore that request is granted. So, excuse me. So here in the progress, the processes that's being entered into the critical section, those processes that were not able to avail or will not able to access the critical sections are bounded to wait, because there will be these processes will be next to queue or are queuing in the critical section problem. So there are also some classical problems of synchronization. So we have the bounded buffer problem, the readers-writers problem, the dining philosopher problems. So I just included this here, but I will not be going to elaborate this one. All this is just representation. So the most common problems when it comes to process synchronization are already discussed earlier. So we have the producer-consumer problem, especially the three common problems. And then we also have the race condition, and then we also have the critical section problem. Now, I hope you were able to understand, and then I hope that if you have any questions or clarifications along the way, please let me know, and please don't hesitate to message me in our group chat.